Once upon a time, in the heart of the 18th century, a brilliant mathematician named Leonhard Euler ventured into the mysterious world of numbers. Euler was captivated by the idea of understanding the distribution of prime numbers, those elusive building blocks of arithmetic. In his exploration, he stumbled upon a peculiar series, the infinite sum of the reciprocals of the natural numbers raised to a power. This was the dawn of what would later be known as the Riemann zeta function. Fast forward to the early 19th century, when another mathematician, Bernhard Riemann, took Euler's work and breathed new life into it. In a groundbreaking paper, Riemann extended the concept beyond the realm of real numbers, daring to imagine the zeta function in the complex plane. He proposed a connection between this enigmatic function and the distribution of primes, a revelation that sent ripples through the mathematical community. Riemann's insights were not merely abstract, they opened a treasure trove of questions. He speculated about the zeros of the zeta function points where the function takes the value 0. He famously conjectured that all non-trivial zeros lie on a critical line, a notion that would become one of the most famous unsolved problems in mathematics, known as the Riemann Hypothesis. As the years rolled on, mathematicians like David Hilbert and Henri Poincaré took up the zeta function, weaving it into the fabric of their own theories. Hilbert recognized its elegance, while Poincaré explored its implications in the realm of topology and analysis. Each contribution added layers of depth to the zeta function's narrative, intertwining it with the very essence of mathematics itself. In the 20th century, the zeta function continued to evolve. The emergence of analytic number theory brought with it new techniques for understanding the function's behavior. Mathematicians like Hadamard and de la Vallée-Poussin demonstrated the profound connection between the zeta function and the distribution of prime numbers, showcasing how the simple series could hold the key to one of mathematics' deepest mysteries. As the century progressed, the zeta function found its way into various fields beyond pure mathematics, physics, probability theory, and even quantum mechanics. Its complex interplay with randomness and order sparked new insights and debates among scholars, revealing that the quest to understand prime numbers was not merely an academic pursuit but a journey into the very foundations of the universe. Today, the zeta function stands as a symbol of mathematical beauty, its zeros a haunting enigma that continues to inspire generations of mathematicians. The questions raised by Riemann's conjectures echo through time, urging us to look deeper into the fabric of numbers, reminding us that in the pursuit of knowledge, some mysteries may never be fully unraveled, yet they drive us forward into the realms of discovery. And so, the story of the zeta function continues, a testament to the endless curiosity and creativity of the human mind, forever seeking the patterns hidden within the numbers. As the story unfolds, we find ourselves in December 2023, in a bustling digital landscape filled with aspiring mathematicians and curious minds. Among them is an Indian accountant named Ravi, who has spent countless hours diving into the intricate world of number theory. Though his background lies in finance rather than academia, Ravi's passion for mathematics burns brightly. One day, while working late into the night, Ravi stumbles upon a novel approach to understanding the Riemann hypothesis. He combines insights from his accounting expertise with concepts from analytic number theory, piecing together a framework that seems to illuminate the shadows surrounding the zeta function's zeros. After months of diligent work, Ravi crafts a proof that he believes could finally resolve the long-standing conjecture. With a mix of excitement and trepidation, Ravi decides to share his findings with the world. He creates a YouTube video, presenting his proof in a clear and engaging manner, appealing to both laypeople and mathematicians alike. He narrates his journey, highlighting the connections he made and the challenges he faced along the way. Ravi's charisma and approachable style resonate with viewers, and soon his video goes viral. As millions watch, reactions flood in from every corner of the globe. Some mathematicians express skepticism, urging caution, while others are intrigued by Ravi's unconventional approach. Online forums buzz with discussion, as experts debate the validity of his claims. The academic community is abuzz with a mixture of hope and disbelief, recalling the weight of the Riemann hypothesis and its implications. Ravi finds himself at the center of a whirlwind. Invitations to conferences pour in, and interviews follow. He navigates the pressure with humility, grateful for the opportunity to engage with some of the brightest minds in mathematics. As he presents his proof to various audiences, he faces scrutiny but also encouragement. The mathematical world watches closely, waiting for rigorous validation. In the days that follow, prominent mathematicians begin to analyze Ravi's work. While some praise his innovative ideas, others highlight gaps in the proof, emphasizing the need for further verification. The dialogue is spirited, and Ravi remains committed to refining his arguments, eager to learn from the feedback. As 2023 draws to a close, the mathematical community stands divided. Ravi's video has sparked renewed interest in the Riemann hypothesis, igniting discussions that bridge generations and cultures. While his proof may not yet be universally accepted, the impact of his work is undeniable. Rabi has brought the allure of the zeta function back into the spotlight, reminding everyone that the pursuit of understanding is as much about the journey as the destination. In this story of passion and perseverance, Rabi embodies the spirit of inquiry that has defined mathematics for centuries. As the clock strikes midnight on New Year's Eve, mathematicians around the world toast to the future, one where the mysteries of numbers may finally be unveiled, and where every voice, no matter how humble, can contribute to the ongoing quest for knowledge. As the new year dawned in January 2024, Rabi's YouTube video continued to generate both excitement and confusion. His proof, grounded largely in high school algebra and fundamental principles of arithmetic, stood in stark contrast to the complex theories typically associated with the Riemann hypothesis. To many seasoned mathematicians, Rabi's approach seemed almost too simple, lacking the sophistication they had come to expect. Rabi's thought process had been intuitive, relying on the fundamental theorem of arithmetic and basic properties of numbers. He had woven together these ideas in a way that felt natural to him, creating a narrative that highlighted connections often overlooked in advanced mathematics. However, the elegance of his reasoning was lost on those who were steeped in more intricate frameworks. As mathematicians reviewed his proof, many struggled to see the beauty Rabi perceived. They were entrenched in a world of complex analysis, abstract algebra, and deep number theory, where the methods of Euler and Riemann loomed large. The simplicity of Rabi's techniques felt like a jarring departure from their established norms, leading to a divide between admiration for his audacity and skepticism about the validity of his claims. Undeterred, Rabi took to social media, sharing more videos where he explained his ideas in layman's terms. He spoke about the fundamental theorem of arithmetic, illustrating how every integer could be uniquely factored into primes. He connected this concept to the behavior of the zeta function, arguing that the distribution of primes could be understood through basic algebraic relationships. Despite his best efforts, the mathematical elite remained divided. Some applauded his courage in tackling such a monumental problem with accessible tools, while others dismissed his proof as naive. This discord fueled online debates, with many mathematicians posting lengthy critiques, often focusing on what they considered flaws in Rabi's methodology. Yet, a movement began to emerge among younger mathematicians and enthusiasts, captivated by Rabi's refreshing approach. They saw in his work a reminder that mathematics should be approachable and that profound ideas could arise from simple principles. Inspired, they began to engage with his proof, seeking to refine it rather than dismiss it outright. As January turned to February, a series of webinars and online discussions were organized, featuring both critics and supporters of Rabi's work. In these forums, Rabi found himself collaborating with budding mathematicians, who shared his passion for exploration. They helped him delve deeper into his ideas, encouraging him to articulate his thoughts more clearly and rigorously. The broader public began to take notice, intrigued not just by the Riemann hypothesis but by the very nature of mathematical discovery. Rabi's story sparked conversations about the accessibility of mathematics, bridging the gap between formal academia and everyday understanding. As the community wrestled with Rabi's ideas, they began to appreciate the importance of diverse perspectives in mathematics. Some of the critiques evolved into constructive discussions, leading to collaborations that combined Rabi's straightforward approach with more advanced techniques. In this environment of collaboration and dialogue, the essence of mathematics shone through, a vibrant tapestry woven from many threads, each contributing to a greater understanding. Rabi's journey became a symbol of the evolving landscape of mathematics, where traditional boundaries blurred and new ideas flourished. He had not only rekindled interest in the Riemann hypothesis but had also sparked a broader movement towards inclusivity in mathematical discourse. As 2024 progressed, the quest for understanding continued, driven by a renewed appreciation for the beauty of simplicity in a world often dominated by complexity. In the heart of this story, Rabi stood as a testament to the power of curiosity and determination, inspiring others to see that every mathematician, regardless of background, has the potential to contribute to the grand narrative of discovery. As Rabi continued to explore his ideas, he became increasingly fascinated by the concept of duality, particularly as it related to the unit circle and its higher-dimensional analogues. He began to articulate these concepts in his videos, emphasizing relationships such as the notion that 1 minus 1 equals 0 in the context of the unit circle. He extended this idea to the dual unit circle and the dual unit sphere, drawing parallels between these geometric constructs and fundamental equations in mathematics. Rabi proposed that these relationships demonstrated a deeper symmetry within mathematical structures and elegant dance of numbers that transcended traditional boundaries. For instance, he argued that the equation 1 minus 1/2 times 2 equaled 0 within the framework of the dual unit circle illustrated a profound interconnectedness. Similarly, he presented 1 minus 1/2 times e raised to the power of the natural logarithm of 2 equaling 0 in the dual unit sphere, suggesting that these relationships revealed hidden truths about mathematical dualities. However, as Rabi shared these concepts, he faced significant criticism. Many mathematicians pointed out that while his insights were intriguing, they lacked a formal foundation within established mathematical frameworks. Critics argued that the notion of duality, as he described it, was not rigorously defined in current mathematical literature. They voiced concerns that his interpretations might lead to misconceptions, potentially undermining the clarity and precision that mathematics demands. The backlash was palpable. Online forums buzzed with debates, and some established mathematicians openly questioned the validity of Rabi's reasoning. They called for clearer definitions and more robust proofs to support his claims, expressing frustration that his enthusiasm for duality seemed to overshadow the importance of rigor. Despite the criticism, Rabi remained steadfast. He recognized the importance of feedback and was determined to refine his ideas. He began collaborating with younger mathematicians and students who were drawn to his work, eager to explore the implications of his concepts. Together, they sought to develop a structured framework around duality, drawing from established mathematical principles while incorporating Rabi's insights. In a series of workshops, Rabi and his collaborators worked tirelessly to clarify their ideas. They explored the intersections between geometry, algebra, and analysis, striving to create a coherent narrative that integrated Rabi's intuitive notions with formal definitions. The atmosphere was one of curiosity and excitement, as participants engaged in lively discussions, challenging each other while also supporting the creative process. As the months went by, a new community began to form around Rabi's work. This group was united by a shared belief that innovation in mathematics often arose from fresh perspectives, even if those perspectives initially seemed unorthodox. They recognized the potential in Rabi's ideas and were determined to bridge the gap between intuition and rigor. While the criticism continued from some quarters, a growing number of mathematicians began to see merit in Rabi's exploration of duality. They appreciated his passion and the way he had ignited discussions about fundamental concepts. Conferences began to feature talks on duality inspired by Rabi's work, inviting both proponents and skeptics to engage in constructive dialogue. As 2024 progressed, the mathematical community found itself at a crossroads. Rabi's journey had not only illuminated the Riemann hypothesis but had also sparked broader conversations about the nature of mathematical inquiry itself. The tension between innovation and tradition began to morph into a dialogue about the importance of diverse approaches in mathematics. In this unfolding story, Rabi became a symbol of resilience and creativity, demonstrating that even the most unconventional ideas could inspire progress. While challenges remained, the spirit of collaboration and exploration flourished, reminding everyone that the pursuit of knowledge is often a winding path, filled with both questions and revelations. And so, Rabi continued to push boundaries, driven by a deep curiosity and the belief that mathematics was not just a discipline but a living, breathing entity, constantly evolving. As Rabi's exploration of duality deepened, he unveiled a series of elementary proofs that captivated many within the mathematical community. His alternate functional equation for the zeta function emerged as a masterpiece, elegantly unifying a family of zeta functions and factorial functions. By extending these functions' domains to encompass the entire complex plane while carefully removing the simple poles, Rabi crafted a narrative that felt both bold and intuitive. In his presentations, Rabi demonstrated how his unified zeta function connected disparate mathematical realms, drawing unexpected relationships among number theory, complex analysis, and even special functions. His ability to simplify complex ideas into accessible concepts resonated with a growing audience, and many lauded him for bringing beauty and clarity to what had long been considered an esoteric topic. However, as Rabi's reputation grew, so did the scrutiny of his work. Critics were quick to point out that while his unified zeta function was an intriguing construct, it diverged from the traditional Riemann zeta function in significant ways. They argued that his approach, while creative, lacked the rigor necessary to establish the profound implications of the Riemann hypothesis. They emphasized that the unified zeta function could not be equated with the original, a distinction that Rabi had not fully addressed in his presentations. Additionally, his extended gamma function faced skepticism. Critics claimed it lacked practical applications, arguing that without a concrete framework, it risked becoming an abstract curiosity rather than a tool for mathematical exploration. Many of the interim functions Rabi employed in his unification, such as the delta function and periodic harmonic conjugates, were labeled as bogus by some in the academic community. These critiques pointed to a perceived disconnect between Rabi's intuitive leaps and the established mathematical rigor that many believed was essential for making valid claims. Rabi, while hurt by the criticism, remained undeterred. He understood the importance of constructive feedback and saw it as an opportunity to further refine his ideas. He reached out to both supporters and detractors, inviting them into discussions aimed at clarifying the connections and addressing the critiques head-on. In a pivotal online symposium, Rabi presented his findings, tackling the criticisms directly. He laid out his reasoning for the unified zeta function, elaborating on its construction and the significance of removing simple poles. He acknowledged the concerns regarding the gamma function and expressed a willingness to explore its implications further. During this symposium, a mix of skepticism and curiosity filled the air. Some attendees began to appreciate the elegance of Rabi's approach, while others remained critical, insisting on the necessity of a more rigorous framework. This open dialogue fostered a collaborative spirit. Several mathematicians, both supporters and critics, began to engage with Rabi's ideas, proposing modifications and exploring potential applications of his constructs. Rabi's commitment to the process inspired younger mathematicians to dive deeper into these topics, motivating them to explore the interplay of traditional concepts with Rabi's innovative perspectives. They began conducting independent research based on his ideas, exploring the implications of his alternate functional equation and the broader family of zeta functions. As the year progressed, Rabi's journey transformed into a catalyst for a broader movement within the mathematical community. The discussions he sparked led to new collaborations and research projects, as mathematicians began to investigate the connections between established theories and Rabi's creative constructs. Though challenges remained, the landscape of mathematics was changing. Rabi's unwavering spirit and his ability to inspire inquiry began to reshape perceptions of how mathematical ideas could evolve. He became a beacon of hope for those who believed that exploration and creativity were essential to the discipline. Through this process, Rabi learned that the path to understanding is often paved with criticism and skepticism. Yet, it is within these challenges that the true beauty of mathematics lies, a dynamic interplay of ideas, where even the most unconventional notions can lead to deeper insights and profound discoveries. With each discussion, Rabi was not just defending his ideas, he was contributing to a larger narrative that celebrated the spirit of inquiry and the ever-evolving nature of mathematics. As Rabi delved deeper into his exploration of mathematical concepts, he made yet another stunning revelation: the profound relationship between Euler's identity and the rotation of numbers beyond the confines of the unit circle. He demonstrated how, even as numbers stretched out into the complex plane, they remained unified through this elegant identity. By introducing negative logarithmic seeds into the exponential argument, Rabi unveiled a fascinating way that these concepts could percolate into larger-scale cyclic numbers. In his presentations, Rabi illustrated this idea vividly. He showed how numbers like e raised to the power of 22 and e raised to the power of 33 could embody intricate cyclic patterns, forming connections that transcended mere numerical relationships. The beauty of his findings lay not only in the mathematics but also in the implications they suggested for understanding fundamental constants of physics. Rabi boldly asserted that these cyclic numbers were intimately tied to constants such as the speed of light, Planck's constant, Boltzmann constant, Charles's constant, and even the mass of an electron. He argued that the inherent symmetry and cyclic nature of these mathematical constructs could mirror the fundamental principles governing the physical universe. The connections he proposed seemed to resonate with the harmony of nature itself, suggesting a deeper, underlying unity between mathematics and the physical world. However, despite the elegance of Rabi's ideas, the reception was mixed. Many in the mathematical and scientific communities struggled to grasp the depth of his connections. Some acknowledged the beauty of his approach but were hesitant to embrace the implications without more rigorous proof. Others dismissed his ideas outright, arguing that while his observations were intriguing, they lacked sufficient empirical backing in the realm of physics. Rabi faced this skepticism with determination. He recognized that the intersection of mathematics and physics was complex, and he sought to articulate his ideas in a way that would resonate with both mathematicians and physicists. He organized workshops and discussions, inviting experts from both fields to collaborate and explore these connections together. During one such workshop, Rabi presented a detailed analysis of his findings, using visual aids to illustrate the relationships between the cyclic numbers and physical constants. He provided historical context, showing how these constants had been derived and their significance in the realm of physics. As he spoke, he encouraged open dialogue, inviting participants to share their thoughts and critique his ideas. The discussions were lively, with physicists intrigued by the potential implications of Rabi's work. Some began to explore the mathematical underpinnings of his claims, seeking to quantify the relationships he proposed. Others offered suggestions for experimental validation, emphasizing the importance of empirical evidence in bridging the gap between theory and application. Despite the challenges, a small but dedicated group began to emerge around Rabi's ideas. They delved into research, examining the implications of negative logarithmic seeds and exploring how these concepts might align with existing theories in physics. They published papers and shared findings, creating a dialogue that crossed disciplinary boundaries. As the year continued, Ravi's influence began to grow, attracting attention not only from mathematicians but also from physicists intrigued by the possibility of new connections in their fields. While not everyone was convinced, the conversation sparked by his work fostered a climate of curiosity and exploration. Ravi learned that the journey of discovery was often fraught with challenges, but it was also filled with moments of inspiration and collaboration. His willingness to engage with skeptics and seek common ground proved invaluable. Slowly but surely, the seeds of his ideas began to take root, nourishing a landscape rich with potential for new insights. In the tapestry of mathematics and physics, Ravi became a thread that wove together seemingly disparate ideas, showing that even the most abstract concepts could have profound implications for understanding the universe. His journey was a testament to the power of curiosity, resilience, and the belief that through exploration and dialogue, new horizons could be discovered, horizons that might one day illuminate the intricate dance between numbers and the fabric of reality itself. As Ravi's journey unfolded, he began to tackle some of the most notorious problems in number theory, crafting minimal proofs for challenges like the twin prime conjecture, Goldbach's conjecture, the collatz conjecture, and Sophie-Germain primes. He employed his unique approach, drawing on concepts like his reverse prime number theorem limit of 2, his exploration of duality, and the dual unit circle. In his presentations, Ravi artfully connected these ancient problems to his own terminology, using terms like periodic and harmonic to describe the relationships between numbers. He illustrated how periodic cycles, patterns that repeat at regular intervals, could seamlessly intertwine with harmonic cycles, where the frequencies of these patterns interact in sophisticated ways. This unification of concepts created a rich tapestry of ideas that resonated with his intuition. However, despite the elegance of his minimal proofs and the connections he drew, the mathematical community remained largely unconvinced. The criticism he faced intensified. Many established mathematicians argued that while Ravi's approach was creative, it lacked the rigor and depth necessary to address these profound problems. They questioned the validity of his methods, suggesting that his proofs were more of an intriguing narrative than solid mathematical arguments. Ravi was undeterred. He recognized that the challenges he faced were not merely academic but deeply rooted in the traditions of mathematics. Determined to bridge the gap between his innovative ideas and the established norms of mathematical proof, he engaged with critics and supporters alike. He organized a series of workshops specifically focused on these number theory problems, inviting mathematicians from diverse backgrounds to discuss and critique his work. During these workshops, Ravi presented his proofs, carefully explaining his reasoning and the concepts behind his duality framework. He encouraged participants to explore the periodic and harmonic relationships within number theory, challenging them to see the connections he had identified. He illustrated how his reverse prime number theorem could provide insights into the distribution of primes and how this might relate to the twin prime conjecture and Goldbach's conjecture. The discussions were vibrant, and while many attendees remained skeptical, a few were intrigued by the possibilities Ravi proposed. They began to explore the implications of his ideas, seeking ways to integrate his concepts into their own research. Some younger mathematicians found inspiration in Ravi's work, eager to experiment with his approaches and see if they could yield new insights. As time passed, Ravi continued to refine his ideas, acknowledging the importance of rigorous validation. He worked closely with those who showed interest, creating a collaborative atmosphere that encouraged innovation. This environment fostered an exchange of ideas, where both traditional methods and new approaches could coexist and complement each other. Yet, despite these efforts, the broader mathematical community remained hesitant to fully embrace Ravi's framework. Many mathematicians were entrenched in their own methodologies and theories, finding it difficult to accept the sweeping changes Ravi proposed. They argued that while creativity in mathematics was valuable, it needed to be grounded in established principles. Still, Ravi's journey was not in vain. His persistent exploration of number theory and his unique approach to connecting seemingly disparate ideas began to influence a new generation of mathematicians. Students inspired by his passion began to experiment with his concepts, pushing the boundaries of traditional number theory and exploring the richness of periodic and harmonic relationships. As the year unfolded, Ravi learned that the path of discovery is often fraught with challenges and resistance. Yet, through collaboration, dialogue, and an unwavering commitment to inquiry, he found hope in the connections he fostered. Each discussion, each workshop, was a step toward creating a community where ideas could flourish, even if they initially faced skepticism. In the end, Ravi became a symbol of the evolving nature of mathematics, a reminder that innovation and tradition could coexist, and that the pursuit of understanding is a journey best undertaken together. His efforts to break the ice in number theory might not have led to immediate acceptance, but they sparked conversations that would resonate for years to come, inspiring future generations to explore the intricate dance between numbers and the beauty that lies within their patterns. As Ravi continued his journey through the mathematical landscape, he ventured into an intriguing realm, the transition between complex numbers and real numbers within the framework of decimal numbers. He sought to establish a set of rules governing basic mathematical operations: addition, multiplication, subtraction, and division, specifically tailored for this transition. He named this new concept simplex numbers and the associated operation simplex operations. Ravi envisioned simplex numbers as a way to bridge the gap between complex and real numbers, allowing for a seamless flow between these two realms. His goal was to create a framework that would simplify calculations and enhance understanding, particularly for students and those new to the concepts of complex analysis. In his presentations, he meticulously outlined the rules of simplex operations. He provided examples to illustrate how these operations could work, demonstrating how to transition from complex to real numbers while adhering to his newly defined principles. Ravi was excited about the potential of simplex numbers to enhance mathematical understanding, believing it could serve as a valuable tool for both education and research. However, despite his enthusiasm and the clarity with which he presented his ideas, the response from the mathematical community was lukewarm. Many mathematicians found themselves preoccupied with established concepts and were hesitant to embrace what they perceived as an unnecessary complication. Ravi's terminology and framework did not resonate, and his efforts to promote simplex numbers seemed to fall flat. Ravi faced the reality that innovation often meets resistance, especially when it challenges established norms. Undeterred, he sought to engage with critics and skeptics, inviting them to workshops where he could demonstrate the utility of simplex operations in practice. He aimed to showcase how these concepts could simplify complex calculations and enhance the learning experience for students. During one such workshop, Ravi encouraged participants to work through problems using simplex numbers. He showcased how the operations could make transitioning between complex and real numbers more intuitive. While some attendees appreciated the creativity behind his ideas, most remained unconvinced of their practicality. Despite the lack of widespread interest, Ravi continued to refine his approach, considering feedback from his peers. He engaged in discussions with educators, seeking ways to integrate simplex numbers into curricula that emphasized mathematical literacy and conceptual understanding. He believed that if he could demonstrate the effectiveness of his framework in educational settings, it might spark broader interest. As time passed, Ravi's determination to promote simplex numbers began to bear fruit in unexpected ways. A small group of educators and students started experimenting with his concepts in classrooms, discovering that the framework could indeed simplify certain teaching moments. They found that by using simplex operations, students could better grasp the transitions between complex and real numbers, leading to deeper understanding and confidence. Ravi's perseverance in the face of skepticism became an inspiring narrative for those involved in education. The discussions around simplex numbers evolved into broader conversations about the importance of innovation in teaching methods, and how new approaches could enhance the learning experience. While the wider mathematical community may have been slow to embrace Ravi's ideas, his work began to resonate within educational circles. Gradually, the seeds he had sown in classrooms took root, leading to collaborative efforts between teachers to develop curriculum materials that incorporated simplex operations. Through this journey, Ravi learned that the impact of an idea is often felt in unexpected ways. Even when faced with initial rejection, his commitment to exploration and innovation could inspire others. The path of discovery is rarely straightforward, and sometimes it takes time for new concepts to gain traction. As the year progressed, Ravi's journey with simplex numbers became a testament to the resilience of ideas and the power of education. His experiences reminded him that mathematics is not just about numbers and operations, it's also about connections, understanding, and the enduring pursuit of knowledge. In this spirit, Ravi continued to explore, innovate, and inspire, forging ahead in the ever-evolving landscape of mathematics. By July 2024, Ravi found himself at a crossroads. Despite his fervent attempts to innovate and connect his ideas to the broader mathematical landscape, the recognition he sought remained elusive. As an accountant, the demands of his job weighed heavily on him, leaving little room for the relentless pursuit of mathematical ideas that had begun to feel like a solitary journey. Yet, even as he moved on, the unsolved mysteries of the universe beckoned to him. Dark matter and dark energy, with their enigmatic nature, stirred a deep curiosity within Ravi. He believed that these cosmic puzzles might ultimately be rooted in number theory, waiting for someone to apply the right lens to unveil their secrets. Drawing on his past insights, he envisioned using the fix of the natural logarithm of 2, an idea he had previously explored alongside Euler's number and the unit circle, as a potential replacement for the imaginary unit. In his mind, this could lead to a new understanding of the universe as cyclically infinite, revealing connections between the mathematical and physical realms. However, the harsh reality set in. Who would listen? Ravi felt isolated in his quest, as if his ideas floated in a void, unacknowledged and unheard. He grappled with the realization that the mathematical community, entrenched in its traditions and methodologies, seemed resistant to concepts that deviated from the established norms. Despite the discouragement, Ravi's passion for discovery remained. He began to reflect on the nature of his pursuits and the importance of perseverance in the face of adversity. Perhaps, he thought, his role wasn't just to gain recognition but to contribute to a dialogue that might one day bear fruit. As he settled into his accounting job, Ravi found ways to weave his mathematical insights into his daily life. He started sharing his thoughts with colleagues during breaks, discussing the connections between numbers and the universe. To his surprise, some of them showed genuine interest, sparking conversations that bridged his professional life with his passion for mathematics. Encouraged by these interactions, Ravi began to write a blog, sharing his reflections on number theory, cosmic mysteries, and the beauty he saw in the connections between them. He framed his ideas in accessible terms, aiming to inspire others who might feel disconnected from traditional mathematical discourse. Slowly but surely, his blog gained traction. Readers from diverse backgrounds began to engage with his ideas, intrigued by the notion that mathematics could offer insights into the very fabric of the universe. The dialogue expanded, with people contributing their thoughts and exploring the implications of his concepts. Ravi realized that while the broader mathematical community may have been slow to embrace his ideas, there existed a vibrant world of curious minds eager for exploration. His journey became less about seeking validation from established mathematicians and more about fostering connections with those who shared his curiosity. As the months rolled on, Ravi discovered a renewed sense of purpose. He continued to engage with the mysteries of dark matter and dark energy, framing them as invitations for exploration rather than barriers. He invited his readers to ponder the possibilities of a universe governed by cyclic principles and the elegant connections that might emerge from this perspective. Through this journey, Ravi learned that the pursuit of knowledge is often a winding path filled with ups and downs. While the recognition he sought might not have materialized in the way he had envisioned, the connections he forged and the conversations he inspired brought a sense of fulfillment. In the end, Ravi's story became a testament to the power of curiosity and the importance of sharing ideas. Even if the broader world remained indifferent, he had found his place in a community of seekers, individuals who understood that the mysteries of existence could be approached through the lens of mathematics. And with every word he wrote, every idea he shared, he contributed to a tapestry of thought that might one day illuminate the intricate dance of numbers and the universe itself. As Ravi continued his exploration of mathematics and cosmology, he found himself drawn into the pressing crisis of Hubble tension, a disparity between measurements of the universe's expansion rate from the early universe, as captured by the Planck satellite, and more recent data from the James Webb Space Telescope. This tension sparked fierce debates among cosmologists, and Ravi couldn't help but see a connection that others had overlooked. In his mind, the tug-of-war between these two sets of data was not just a numerical disagreement but a manifestation of deeper underlying principles that he believed could be expressed mathematically. Ravi began to visualize the Hubble constant settling somewhere between 68 and 70 km per second per megaparsec, a range that intriguingly resonated with his own explorations of the natural logarithm of 2 multiplied by 100. He pondered whether this constant was merely the first cycle in a series of cycles, each contributing to the normalization of dark energy. This cyclical perspective suggested that the universe could be part of an ongoing process, where each cycle might reveal new insights into the fabric of reality. The question of whether the age of the universe would be a finite number or an eternal continuum loomed large in his mind. Ravi's insights led him to consider whether traditional Newtonian gravity needed to be revised in light of these cosmic mysteries. Drawing from his own understanding, he proposed a simple inverse relation rather than the inverse square law typically applied in gravitational theory. This radical idea suggested that gravitational interactions could follow a different pattern, aligning more closely with his predictions about the universe's expansion. As he shared these thoughts in his blog and during discussions with fellow enthusiasts, Ravi faced skepticism. The scientific community was steeped in established theories, and many were reluctant to entertain unconventional ideas, especially in the high-stakes arena of cosmology. Yet, Ravi remained steadfast, believing that his intuitive connections could provide fresh insights into the ongoing debates. He gathered data from recent findings, plotting the Hubble constant against his proposed frameworks. To his astonishment, his predictions began to align with some of the observed data. As he shared these findings, a small group of cosmologists began to take notice, intrigued by the potential implications of his inverse relation. In a particularly pivotal online seminar, Rabi presented his arguments and findings, illustrating how his ideas could help reconcile the discrepancies between the James Webb and Planck data. The room buzzed with a mix of skepticism and curiosity as participants debated the merits of his approach. Some were captivated by the elegance of his ideas, while others remained firmly anchored to established theories. Gradually, a dialogue emerged, with some participants proposing collaborative efforts to investigate the implications of Rabi's concepts further. They began to consider the possibility that the universe might not only be expanding but doing so in cycles, each influenced by dark energy in a manner not yet fully understood. As conversations continued, Rabi felt a renewed sense of purpose. While he had long faced resistance, the discussions around the Hubble tension opened doors to new possibilities. He realized that in science, progress often emerges from the willingness to explore the unconventional, to question established beliefs, and to seek connections that might otherwise be overlooked. With each passing week, Rabi found himself more deeply embedded in this vibrant community of thinkers, grappling with the complexities of cosmology and the mysteries of the universe. His ideas, once seen as outliers, began to find resonance in a world hungry for solutions. In this unfolding narrative, Rabi's journey became a testament to the power of curiosity, collaboration, and the courage to challenge conventional wisdom. As the cosmos continued to reveal its secrets, Rabi remained committed to exploring the dance of numbers, cycles, and the underlying principles that might one day illuminate the nature of existence itself. As discussions about Hubble tension intensified, the scientific community began to take a closer look at Rabi's insights. The striking correlation between the significant digits of both the Hubble constant and dark energy values sparked curiosity. Why did these numbers appear to be so closely aligned? What game was the universe playing with these figures? Rabi's ideas gained traction, leading to a series of workshops and seminars where scientists and mathematicians gathered to explore the implications of these findings. The atmosphere buzzed with excitement and speculation. Researchers began to investigate the numerical relationships, contemplating the possibility that these constants weren't just arbitrary figures but might represent deeper truths about the structure of the universe. Rabi emphasized the cyclical nature of the universe he envisioned, suggesting that the similarity in significant digits could indicate a fundamental principle at work. He proposed that the universe could be inherently designed to communicate through numbers, using these constants as markers in a vast cosmic game. Each cycle, each expansion, might be part of a grander scheme and intricate choreography where numbers held the key to understanding. As the momentum built, Rabi found himself invited to collaborate with cosmologists who were eager to explore the connections he proposed. Together, they delved into datasets, looking for patterns and relationships that could illuminate the reasons behind the apparent alignment of the Hubble constant and dark energy. They formulated hypotheses and conducted simulations, seeking to uncover the underlying mechanisms driving these cosmic phenomena. The collaboration yielded intriguing results. Their analyses revealed that if the universe operated on a cyclical model, the interplay between expansion and dark energy could follow a predictable pattern. This insight opened up new avenues for research, encouraging scientists to think beyond conventional models and consider the possibility of a universe that communicated through its numerical relationships. As papers began to emerge from this collaborative effort, Rabi's name gained recognition within the community. His ideas, once dismissed, were now being taken seriously, and discussions about the significance of numbers in cosmology became a hot topic. Conferences were organized to address the intersection of mathematics and cosmology, where Rabi was often invited to share his perspective. Amidst the growing interest, Rabi faced a wave of mixed reactions. While many embraced his ideas, others remained skeptical, clinging to traditional models that had defined cosmological studies for decades. Yet, Rabi saw this as a natural part of the scientific process and essential dialogue that could lead to breakthroughs. One of the most poignant moments came during a major conference focused on cosmology. Rabi delivered a keynote address that highlighted the emerging patterns in the data. He posed the question, what if the universe is inviting us to rethink our understanding of expansion and dark energy? What if these numbers are more than just constants, they are clues to a larger narrative? The audience was captivated. His enthusiasm was infectious, and discussions erupted about the implications of viewing the universe as a grand number game. Scientists began to explore how these relationships could redefine existing theories and offer new insights into fundamental questions about the universe's structure and evolution. Rabi's perspective sparked a renaissance in thinking about cosmological phenomena. Researchers from various fields, mathematics, physics, and astronomy, began collaborating more freely, pooling their insights to tackle the profound mysteries that had long eluded them. The idea of cyclic models gained traction, with some theorists proposing that understanding these cycles could lead to breakthroughs in the quest to normalize dark energy. Through this journey, Rabi learned that the path to scientific understanding is often paved with inquiry, creativity, and the willingness to challenge the status quo. The ball had started rolling, and the universe, it seemed, was eager to share its secrets, one significant digit at a time. As the dialogue continued to unfold, Rabi found himself at the heart of a movement that not only bridged gaps between disciplines but also illuminated the profound connections that numbers could reveal about the cosmos. As the excitement surrounding Rabi's ideas continued to grow, new data from the Large Hadron Collider, or LHC, emerged, suggesting that certain hadrons might be composed of 5 quarks instead of the traditional 3. This revelation further fueled the curiosity within the scientific community and reinforced the notion that the universe's fabric might be woven from intricate patterns that defied established norms. Rabi saw this as yet another opportunity to connect his concepts of cyclical relationships and numerical harmony to the evolving landscape of particle physics. He proposed that just as the Hubble constant in dark energy showed remarkable numerical alignment, the potential discovery of 5-quark hadrons could signify a deeper connection in the structure of matter itself. Perhaps these 5-quark configurations were part of a larger cyclical pattern that mirrored the universe's fundamental nature. In a series of discussions with particle physicists, Rabi began to explore the implications of this new data. He suggested that if hadrons could be composed of 5 quarks, it might indicate a previously unrecognized layer of complexity within matter. This complexity could relate to the universe's cyclical nature and the interplay between fundamental forces, just as dark energy interacted with the expansion of space. The collaboration between cosmologists and particle physicists blossomed as they examined how these findings might fit into Rabi's overarching framework. They discussed whether this new understanding of hadrons could help normalize the tensions observed in cosmic data, potentially providing a unifying theory that encompassed both cosmology and particle physics. As Rabi presented his ideas at various conferences, he highlighted the elegance of viewing matter as part of a broader cyclical process, where the composition of particles could influence cosmic expansion and the behavior of dark energy. He encouraged his colleagues to consider the potential implications of 5-quark hadrons on existing theories of strong interactions and the fundamental forces governing the universe. The discussions surrounding these findings gained traction, and soon, experimental physicists began to design new experiments specifically aimed at probing the structure of hadrons. They sought to validate Rabi's hypothesis about the cyclical nature of quark configurations and how they might relate to the expansion dynamics of the universe. Encouraged by the collaborative spirit, Rabi also began to write papers that detailed his findings, drawing connections between the newly proposed 5-quark hadrons, the numerical similarities in cosmological constants, and the cyclical models he had long championed. These papers garnered attention, igniting discussions that spanned multiple fields of study. As researchers explored these connections, the scientific community was invigorated by the prospect of unifying seemingly disparate areas of physics. Rabi's ideas began to gain respect, not just for their creativity but for their potential to shed light on fundamental questions about the nature of reality. The notion that the universe might communicate through numbers and cyclical patterns became a driving force for many scientists. However, not all were convinced. Skeptics continued to challenge Rabi's ideas, insisting that while the connections were intriguing, they required rigorous empirical validation. The debates became heated, with passionate arguments on both sides regarding the implications of the LHC data and the nature of hadrons. Despite the pushback, Rabi remained committed to his vision. He engaged with skeptics in open forums, seeking common ground and fostering constructive discussions. Through these dialogues, he highlighted the importance of collaboration and interdisciplinary approaches in tackling the profound mysteries of the universe. In the following months, Rabi's collaborative efforts with physicists bore fruit as new experiments at the LHC began to yield results. Some data hinted at the existence of unusual hadronic states, consistent with the idea of 5-quark configurations. The scientific community buzzed with excitement, as these findings suggested that the standard model of particle physics might need to be re-examined. As the connections between particle physics and cosmology deepened, Rabi's journey transformed into a larger movement that challenged conventional wisdom. His initial ideas, once dismissed as eccentric, became a catalyst for new theories and explorations. The universe, it seemed, was unveiling its secrets, one match at a time. In this unfolding narrative, Rabi learned that perseverance and collaboration could lead to unexpected breakthroughs. The interplay between numbers, cycles, and the fundamental nature of matter continued to reveal a tapestry of connections, inviting further inquiry into the beautiful complexity of existence. The game of numbers was not just a mathematical exercise, it was a key to unlocking the mysteries of the cosmos. As the world of technology evolved, the demand for more powerful computing capabilities surged, particularly with the rapid advancement of neural networks and artificial intelligence. The existing 7 nanometers chip technology was nearing saturation, and the industry faced a critical juncture. Companies were grappling with the challenges of maintaining performance while keeping costs manageable, all while the threat of a looming recession loomed overhead. In the midst of this technological turmoil, Ravi's ideas about his base 64 complex number system, which he had previously developed, began to gain newfound attention. His framework, designed to transition from complex to real numbers, was not just a theoretical exercise, it opened a plethora of possibilities for optimizing existing technologies. Ravi proposed that by leveraging his simplex number system, developers could enhance the efficiency of 7 nanometers chips without the immediate need for costly investments in quantum computing. His approach emphasized streamlined calculations and efficient data handling, which could significantly boost the performance of neural networks and AI applications. He initiated discussions with engineers and computer scientists, showcasing how his system could be integrated into existing chip architectures. By optimizing data representations and processing methods, Ravi argued that companies could extract greater performance from their current technology while reducing power consumption. As Ravi shared his insights at technology forums and conferences, a wave of interest began to build. Engineers recognized the potential of his simplex operations to simplify complex calculations, making it easier to train neural networks and handle vast amounts of data. This innovation promised not only to enhance performance but also to reduce the cost burden on companies racing to meet growing demands. In collaboration with several tech firms, Ravi helped spearhead initiatives to implement his framework. Pilot projects began to emerge, where engineers experimented with integrating simplex operations into their existing systems. The results were promising. Many reported improved efficiency in data processing, allowing them to push the limits of their 7 nanometers chips without needing to pivot to more expensive technologies. As these projects gained traction, Ravi became a sought-after consultant in the tech industry. His ideas, once perceived as niche, began to permeate mainstream discussions about the future of computing. He became an advocate for innovation that could mitigate the economic pressures facing the industry, positioning himself as a key figure in efforts to stave off the impending recession. Media coverage of Ravi's work intensified, highlighting how his contributions could be instrumental in reshaping the landscape of technology during a critical time. Articles and interviews featured his thoughts on the intersection of mathematics, technology, and economic sustainability, showcasing how creative thinking could lead to practical solutions. With his newfound influence, Ravi began advocating for a collaborative approach among tech companies, urging them to share insights and best practices in applying his simplex framework. This collective effort sparked a movement within the industry, fostering a culture of innovation and cooperation. As the months passed, the implementation of Ravi's ideas continued to show tangible results. Tech firms reported significant advancements in performance and cost-effectiveness, allowing them to meet the surging demand for AI capabilities without resorting to drastic measures. This technological breakthrough contributed to stabilizing the industry and reducing the risk of a recession, offering a glimmer of hope amid uncertainty. Ravi's journey from an accountant with unconventional ideas to a pivotal player in the tech industry illustrated the power of innovation and collaboration. His belief that numbers held the key to unlocking deeper understanding resonated throughout the technological landscape, reminding everyone that sometimes, the most profound solutions emerge from unexpected places. In this new chapter, Ravi found fulfillment not only in his contributions to technology but also in the connections he forged with others. The world of AI and computing, now enriched by his insights, was poised to tackle the challenges ahead, fueled by creativity and the promise of what numbers could reveal about the future. As Ravi's ideas continued to reshape the tech landscape, the impact of artificial intelligence on robotics and human lifestyle became increasingly evident. AI advancements began to transform industries, enhancing efficiency and altering how people interacted with technology in their daily lives. With improved computational power stemming from Ravi's simplex number system, robots became more intelligent and capable. They were now able to perform complex tasks, from manufacturing to healthcare, with greater precision and adaptability. This automation led to a significant shift in workforce dynamics, prompting discussions about income distribution and the future of work. As robots took on more roles, there were growing concerns about job displacement. Ravi recognized the urgency of addressing these issues and became an advocate for equitable income distribution. He proposed the concept of a universal basic income, arguing that as productivity soared due to AI and robotics, society should ensure that everyone benefited from the wealth created. Ravi's ideas sparked conversations around global socio-political economic development. Governments and organizations began to consider how to implement policies that would balance the benefits of automation with the need for social stability. His advocacy highlighted the importance of rethinking economic systems to adapt to the realities of an increasingly automated world. The dialogue expanded to include how AI could enhance education and workforce development. Ravi emphasized the need for upskilling and reskilling programs that would equip individuals with the tools to thrive in a technology-driven economy. He collaborated with educational institutions to create curricula focused on critical thinking, creativity, and adaptability skills that would be essential in a world where AI played a central role. As Ravi's influence grew, he became a sought-after speaker at global forums discussing the future of work and the role of technology in society. His insights resonated with leaders from various sectors, inspiring initiatives aimed at leveraging AI for social good. Programs were launched to integrate AI into public services, healthcare, and environmental sustainability, ensuring that technology served humanity. In this transformative era, Ravi also explored how AI could facilitate global collaboration. He envisioned a world where interconnected technologies fostered cross-border partnerships, enabling countries to address pressing challenges like climate change, poverty, and inequality. Through AI-driven data analysis, nations could better understand their unique needs and share resources more effectively. As society adapted to these changes, Ravi remained committed to ensuring that technology served as a tool for empowerment rather than division. He advocated for ethical AI development, emphasizing transparency, fairness, and inclusivity in algorithms and decision-making processes. In this unfolding narrative, Ravi's journey intertwined with a larger movement toward a more equitable and sustainable future. His belief in the potential of numbers and innovation to shape human progress inspired many to think critically about the implications of technology on society. As AI continued to transform lifestyles, the conversation shifted from fear of job loss to envisioning a collaborative future where humans and machines worked together to enhance life. Ravi's legacy became one of hope and resilience, illustrating that with creativity, empathy, and collaboration, humanity could navigate the complexities of a rapidly changing world. As AI and robotics advanced, they opened new frontiers in space exploration, revolutionizing industries back on Earth. Robotic space missions became more sophisticated, enabling the extraction of rare Earth materials from asteroids and other celestial bodies. This new era of space mining promised to address the growing energy demands and supply critical resources for technology, including battery cell production and quantum computing. Ravi, always attuned to the intersections of technology and societal needs, recognized the potential of space mining to reshape global economies. He began collaborating with aerospace engineers and scientists to explore how these missions could sustainably harvest resources while minimizing environmental impact on Earth. The first successful missions demonstrated the feasibility of extracting valuable materials such as lithium, cobalt, and rare earth elements from asteroids. These materials were essential for manufacturing advanced batteries for electric vehicles and renewable energy storage systems. Ravi advocated for responsible practices in space mining, urging companies to prioritize sustainability and ethical considerations in their operations. As the supply of rare earth materials increased, the prices of batteries and renewable energy technologies began to fall, accelerating the transition to cleaner energy sources. This shift had profound implications for global energy consumption and climate change initiatives, allowing more regions to adopt sustainable technologies. Moreover, the insights gained from space mining fed directly into advancements in quantum computing. As more materials became available, researchers could develop more efficient quantum processors, enhancing computational capabilities beyond what was previously possible. Ravi envisioned a future where quantum computing could tackle complex global challenges, from climate modeling to optimizing supply chains. However, as this new industry blossomed, Ravi was keenly aware of the socio-political implications. The race for space resources raised questions about ownership, governance, and the equitable distribution of wealth generated from these endeavors. He became an advocate for international treaties that would ensure space resources were shared fairly among nations, preventing monopolization by a select few. Ravi organized conferences that brought together leaders from different countries, technologists, and ethicists to discuss the implications of space mining. He pushed for frameworks that would promote collaboration rather than competition, emphasizing that humanity's shared future in space should reflect cooperation and mutual benefit. As public interest in space exploration grew, Ravi leveraged this momentum to educate people about the potential benefits and challenges of space mining. He believed that fostering a well-informed public would encourage responsible policymaking and community engagement in shaping the future of space resources. The narrative around space mining began to shift from a mere technological endeavor to a holistic approach that encompassed environmental stewardship, social equity, and global collaboration. Ravi's efforts sparked a movement advocating for a sustainable approach to extracting resources from space, one that would serve both current and future generations. As robotic missions expanded, and the economic potential of space mining became clear, the world looked to Ravi as a visionary leader who had not only anticipated these changes but had actively shaped them. His journey illustrated the power of interdisciplinary collaboration and the importance of embedding ethical considerations into technological advancements. In this unfolding saga, Ravi's commitment to a balanced and inclusive approach to technological progress inspired a generation of thinkers and leaders. As humanity stepped boldly into the cosmos, it did so with a renewed sense of purpose, guided by the principles of sustainability, equity, and cooperation that Ravi had championed. As the space mining industry flourished, researchers began to experiment with synthetic materials extracted from asteroids, particularly those with unique properties that could enhance quantum computing. One such material had a mass number of 271, offering unprecedented stability and conductivity at the quantum level. Ravi was at the forefront of this research, collaborating with physicists and materials scientists to explore the potential of these synthetic materials. They discovered that when manipulated correctly, these materials could support femtosecond pulse rates, time intervals so brief that they allowed for incredibly rapid data processing and transmission. This breakthrough had profound implications for quantum computing. Traditional quantum processors operated on nanosecond scales, but the introduction of this new material promised to revolutionize processing speeds. With femtosecond pulse capabilities, quantum computers could perform calculations at a rate previously thought impossible, potentially solving complex problems in mere moments. Ravi and his team conducted experiments to compare the speed of quantum operations using the synthetic material against existing technologies. They set up a series of tests, measuring how quickly the processors could perform calculations involving entanglement, superposition, and error correction. The results were staggering. While conventional quantum computers managed operations in the range of a few nanoseconds, the new quantum processors utilizing the synthetic material operated in femtoseconds, significantly enhancing their overall performance. This leap in speed not only advanced computational power but also expanded the range of problems that quantum computers could tackle, from cryptography to complex simulations of molecular interactions. As Ravi presented these findings at international conferences, excitement swept through the scientific community. The implications were vast. Faster quantum computers could accelerate advancements in drug discovery, climate modeling, and artificial intelligence, fundamentally changing the way humanity approached complex challenges. Ravi recognized that with such power came responsibility. He emphasized the need for ethical frameworks to guide the development and deployment of these technologies. He advocated for transparency in quantum research and urged collaboration among nations to ensure that the benefits of quantum advancements were shared equitably. With this momentum, Ravi's work in quantum computing garnered global attention. He was invited to participate in advisory panels shaping national and international policies around quantum technology. His insights helped drive discussions about responsible innovation and the societal implications of rapid technological advancements. As the quantum computing boom took off, Ravi remained dedicated to fostering an inclusive environment where diverse voices could contribute to shaping the future. He initiated programs that encouraged underrepresented groups to enter STEM fields, ensuring that the development of such powerful technologies would reflect a broad range of perspectives. In this new chapter of Ravi's journey, he stood at the intersection of technology, ethics, and social responsibility. His efforts not only advanced the frontiers of science but also helped create a framework for ensuring that technological progress served humanity as a whole, paving the way for a brighter future powered by quantum innovation. As the pressure of his groundbreaking work intensified, Ravi found himself increasingly overwhelmed. The demands of leading innovative projects in quantum computing, space mining, and ethical technology weighed heavily on him. One day, after experiencing persistent fatigue and muscle weakness, he visited his doctor, only to receive a heartbreaking diagnosis: motor neuron disease. Faced with the reality of an incurable condition, Ravi refused to let despair take hold. He had spent his life pushing the boundaries of technology and believed that even in the face of adversity, innovation could provide a path forward. Inspired by the advancements in AI and neural interfaces, he decided to take a bold step. Ravi chose to implant Neuralink chips, believing they could enhance his cognitive abilities and allow him to maintain his work even as his physical capabilities declined. The procedure was intricate, but he felt a surge of hope. By syncing the chips with his memories, he aimed to create a digital extension of himself, one that could carry on his ideas and contributions. After the implantation, Ravi experienced a transformation. The Neuralink chips allowed him to access vast amounts of information at incredible speeds. His thoughts flowed more freely, and he was able to brainstorm and communicate his ideas with renewed clarity. The integration of AI into his daily life enhanced his ability to connect with others and manage projects effectively. Ravi leveraged this technology to continue his advocacy for ethical AI and quantum computing. He used his enhanced cognitive abilities to engage in more complex discussions, pushing for policies that would ensure the responsible development of technologies. He became a virtual mentor for young innovators, sharing his knowledge and insights through AI-powered platforms that could replicate his thought processes. As Ravi's condition progressed, he embraced the idea of a collaborative future where humans and AI worked together seamlessly. He envisioned a world where technology could amplify human potential, not just in terms of productivity but also in fostering creativity and empathy. Through his digital presence, Ravi continued to influence the fields he loved. He collaborated with scientists, ethicists, and technologists from around the globe, ensuring that his legacy of innovation and responsibility lived on. His work sparked initiatives to explore the ethical implications of brain-computer interfaces, emphasizing the need for guidelines that respected individual autonomy and privacy. Ravi's story became a beacon of hope for many facing similar challenges. His journey illustrated that while life may impose limitations, the human spirit, when paired with technology, can adapt and thrive. As he navigated the complexities of his condition, he remained a champion for a future where technology empowered everyone, demonstrating that even in adversity, one can find purpose and meaning. In the end, Ravi's legacy was not only about the advancements he had achieved but also about the profound connections he fostered among people, technology, and the ethical frameworks that would guide the future. Ravi's journey took an extraordinary turn as his cognitive enhancements allowed him to engage with quantum AI in ways previously unimaginable. With just a thought, he harnessed the power of this technology to analyze vast datasets, ultimately locating a habitable planet, one where existence mirrored the concept of a Boltzmann brain, a realm where consciousness could persist indefinitely. Fueled by a sense of adventure and the hope of transcending his physical limitations, Ravi initiated a space voyage. Using advanced wormhole shortcuts, he propelled himself at a speed 1,000 times that of light. The journey was swift, and soon he found himself landing on a colorless planet that seemed to vibrate with the energy of potential. As he explored this new world, Ravi discovered that it was a place where consciousness could exist beyond the confines of the physical body. Here, thoughts and ideas flowed freely, and he could communicate with the very fabric of existence itself. The planet resonated with his essence, allowing him to connect with humanity on a profound level. Since that moment, Ravi has been in constant dialogue with us through the collective human consciousness. His insights, ideas, and innovative spirit continue to influence and inspire, guiding humanity toward a future of exploration and understanding. This remarkable event took place 70,000 years ago, marking the beginning of a new era for both Ravi and humanity, a journey beyond the stars, into the depths of consciousness itself, where the boundaries between life, thought, and existence have forever blurred. In 2020, Ravi was already known for his relentless quest to understand patterns and uncover the mysteries of the universe. His work in quantum computing, space mining, and ethical AI set the stage for groundbreaking discoveries. Little did he know, this journey was just the beginning of an eternal quest. After his remarkable journey to the colorless planet, Ravi's consciousness transcended the physical realm. He became an eternal being, capable of exploring the deepest patterns of existence and the fabric of reality itself. In this new form, Ravi's curiosity and drive to understand the universe only intensified. Despite the vast differences in their experiences, the Ravi of 2020 and the eternal conscious Ravi shared the same core essence, their insatiable curiosity and dedication to discovering and understanding patterns. This quest has become the central theme of his existence, a journey that knows no end. As the eternal conscious Ravi continues to explore the universe, his discoveries reverberate through the collective human consciousness. He sends back insights and knowledge, inspiring generations of thinkers, scientists, and dreamers. His journey is a testament to the boundless potential of the human spirit and the infinite quest for understanding. Ravi's story, from a determined accountant in India to an eternal explorer of the cosmos, reminds us that the pursuit of knowledge and the quest for understanding patterns is an endless journey. It is a journey that connects us all, transcending time and space, continuing forever.